Okay, welcome everyone. Hope everyone has been enjoying the awesome Solution2 conference. And welcome to my talk today on the tragedy of ToList. My name is Mike Treit. I am a programmer at Microsoft. In October, I actually celebrated my 25th anniversary. So I've been with the company a long time, and I've been doing .NET programming since before .NET was .NET, back when it was. Oh, I'm going to turn my speakers off because I'm hearing myself. Let me just off. Okay. I was just saying I've been doing .NET forever. Before I was a professional programmer, I worked at Microsoft as a software tester. I've always had sort of software quality is something that's always been very important to me, and that's one of the reasons I'm doing this talk is to help raise awareness about things that you might be doing in your code that are leading to much less quality than you could have. The genesis for this talk is that I don't know, 18 months ago, switched to a new team and I started working on some new code bases. And I just saw these patterns in the code over and over and over again. It surprised me where people are doing things that are, hang on one second. I'm going to turn down I can hear myself through my headphones. Okay, hopefully that won't be a distraction now. But I started seeing all these patterns that repeat over and over again. And one of the things I realized is that a lot of this code was written by people that were coming from a different background, like a data science background, very used to doing Python programming. They were new to .NET, they were new to C#, and while they're excellent data scientists, they weren't trained in some of the practices to write really high quality C# code. This talk we've had some great talks in this conference that are focusing kind of on big topics like architecture, vertical slice architecture, and clean architecture, and using a plugin model for building these big systems. This talk is going back to basics, back to the small, to the actual act of when you're writing code, things you should be thinking about. So when you're actually constructing methods that are, solving small little day-to-day programming problems that you then compose into the big actual solutions, this is what this talk is focusing on. And I think there are a lot of things that I find that people, they just don't quite think necessarily of the implications of some of this of the code that they're writing. I have this quote here. It's from an old C++ book from many years ago. The C programmers think memory management is too important to be left to the computer. Lisp programmers think memory management is too important to be left to the user. And it's really drawing the distinction that there are two types of programming environments. One is garbage collected languages. And Lisp is an example of that. And Lisp actually predates C. So garbage collection has been a feature of programming languages since 1959, a lot further back than a lot of people think. And then you have the other side where, you have complete control in something like C or C++, where you're responsible for freeing the memory. There is no garbage collector. Well, .NET, of course, is a garbage collected environment. We're writing C#, we're writing, and we have to keep the garbage collector in mind. The big part of this talk is about what the implications of that are. There was something happening in the C# Discord chat the other day, and I saw this quote asking about GC and advanced stuff. And someone replied and said, the whole point is that you don't have to worry about it. That's why you use the garbage collected language. You just focus on building stuff. You don't have to think about these things. And I kind of fundamentally disagree with this. I think if you're a complete beginner and you're just starting out and you're just figuring out, how loops work and you just want to get some hello world stuff going, you don't have to worry about the garbage collector. But if you're a professional or you're actually starting to build stuff where performance matters, and you're trying to write the highest quality code that you can, you have to understand how the GC works. You have to understand some fundamental concepts. Like what is the stack? What is the heap? What are Gen 1, Gen 2? What does all this stuff mean? And think about what the implications of that are when you're writing your code. There's a bunch of good documentation online. My browser opening. I was going to show it, but not, maybe I have to click over here. Okay, well, go to the Fundamentals of Garbage Collection site. You can look at it yourself. Not sure why my link isn't working. I'm going to have to. That I want to show. Let me do it like this. Okay, there. This is the Fundamentals of Garbage Collection page. It has a ton of good information. You don't have to go through all of this in detail, but I recommend at least going through the basics and understanding sort of. There's a ton of topics here. Get familiar with how GC works, because it has such a implication for how we write our code. My presentation back here. Okay. So along these lines, there's this quote from this talk that I watched a couple years ago on that Brian Cantrell did on should we rewrite the operating system in Rust? And he was coming from a garbage collected language background. Of course, Rust is not garbage collected. In this case, it's JavaScript. A lot of the same ideas apply. But there's this quote that people think that the garbage collector is ruining their process or killing their performance. And as he says, it's not the garbage collector that's ruining their process. It's the garbage that's ruining their process. So a lot of what this talk is about is exactly that. It's about when we create garbage that forces the garbage collector to do a lot of work, and that has some performance implications. I'm not going to start with the main hero of this talk, which is the ToList method, which we're going to get to in a minute. But let's look at this particular example of some code. This is some code. This isn't the exact code, but it was more or less this that I found a while back. At the time, I said to my boss, I think this is some of the worst code I've ever seen. Looking at a single line of code that if you could distill a single line of code into something that's bad, I thought it was good. And look at this piece of code. If you saw this in a code review, would you say, oh, this is fine, I don't see any problems with this? Or would you be repelled, as I was? And if you look at this code, what it's doing is every time this check for match is called, it's creating a hash set. And it's making it so it's case insensitive. And then it is adding these two values for a second. Doesn't really matter what the values are. And then it's saying, does the hash set contain either of those? Is the value that's coming in either of those two values? This code is a dumpster fire. First of all, if you think about what the code is actually doing, every single time it's called, it's constructing this hash set that has a fixed set of values. So there's absolutely no reason that you would need to construct such a thing on every call. And that's checking if the hash set contains the value that we're being asked to check. If you think about what this code is trying to do, it's just trying to see, is this value one of these two things in a case-insensitive way? That's the problem statement. And someone thought, hey, HashSet, big O of 1, it's constant time, it's fast, this is the right way to do this. And so my boss asked ChatGPT, hey, what's wrong with this code? And ChatGPT came back and said, oh, look, why would you new up the hash set every time that we fix that? So ChatGPT fixed the code. It took the hash set, instead of creating a new one every single time the method's called, it just made a static one, so there's just one for the whole process. And then it just checks using that super fast constant time lookup that a hash set gives you is that value one of those values. ChatGPT. This is not a good answer, because if you think about it, you're trying to see, is it A or is it B? The actual fix is just to do a simple equality check. I mean, this is basically an if statement, right? Although in this case, we're just returning Is it first or is it second? If either of those are true, we return true. Otherwise, we return false. You don't need a data structure here. You don't need a hash set. And if you're thinking, well, how can you get faster than a hash set if it's constant time? Then we can get into the whole discussion that, big O notation does not actually tell you anything about actual performance. So that's the example. That's the example of the actual fix. And here's a benchmark showing you the difference. If you see, and we have two cases here, one where the value is actually a match, which was the second case, and one where the value wasn't matched for completeness. And you can see we've got like 1 nanosecond and under 1 nanosecond versus 87, 77, we're renewing it up every time. And still, it's 13 times slower to do the hash set lookup than to just do this simple equality check. And the other thing, it's not just about the performance, it's about the fact that the original solution, which remember was actual code that I found in actual code that we were shipping, that code was creating a bunch of extra work for the garbage collector, which has other implications further on down the lines for causing other performance issues. And that is even potentially more interesting than the actual speed. Now, in this case, it's pretty dramatic, right? It's like 70 to 80 times slower. Usually you don't want that. But even if it was comparatively within the same ballpark of performance, you're still allocating managed heap memory every single time that method is called, that then has to be dealt with by the garbage collector, which means it's going to have to pause your threads potentially and cause hiccups in your code. Which brings us to ToList. So this is a gift someone on the Discord made, I think, kind of to push my buttons a little bit, because I keep sharing these examples where I find people using ToList unnecessarily, and it's an endemic problem. It's amazing how many code samples I can find that have this issue. This is a piece of code that is from yesterday. Friday, I got asked by a colleague to help with the car. He sent me a change, and I went through, and as I was looking at the code, I am now conditioned to every time I see a ToList, my brain goes, wait, this is a ToList call, is it necessary? And as we'll see, if you look at this code closely, you'll see it's not necessary at all. We're calling split, so we're splitting some data, and that's a very common practice. And then we're calling split, and checking if the count is greater than 0. Well, why do we need to call ToList here? Split. What does split return? Split returns an array, and an array has a LINQ property, so you can just replace count here with LINQ, and you don't even need to check the length here actually, because split will return an empty array, so you could loop over the result, but let's leave that alone for a second. We have a second call to split, and then ToList down here, and it's doing the same thing, and then it's saying, oh, I expect 2 tokens, and then I need to index into it. Can you do that on array that comes back from split? Absolutely, you can. So this is just an example of some code that like I just saw yesterday that is doing this unnecessary ToList. And you'll find that, I don't know if it's because all of the code samples online, when they're showing a LINQ and stuff like that, although this isn't LINQ in this case, they almost always have a ToList in there, and so people think this is necessary. Or it's like a reflex that develops over time, and people get in this habit of calling this ToList method when they don't need to. Probably my #1 pet peeve that is causes this pattern is this ForEach method. So people call ToList, which makes a loop, and loops over it, and then throws the list away. So you're allocating memory on the managed heap just so that you can call this ForEach method. Why is that? Is it something that you can, right? And a lot of people think that that's the case. And it's not. ForEach is not a LINQ method. LINQ, LINQ, language integrated query. Let's not select where, all these things that we do all the time. People think that ForEach is part of that. No, ForEach is a method on the list type. And so if you want to call the ForEach method So like here we have LINQ, right? We have ToList ordered by descending. That's a LINQ method that we're going to lazily, when you evaluate you loop over the results, or do something like ToList, which has to enumerate the results. It's going to then sort things in descending order. Well, in this case, we have order by descending, and we want to loop over it. But first, we call ToList because it's a ForEach method that doesn't exist. It doesn't exist on enumerable. It only exists on list. Well, what does that do? That makes an entire copy just so that you can call this method. And if that's a lot of data, that's creating a lot of work for the garbage collector. Guys, just use ForEach. There's absolutely no reason other than I like to do one-liners to call .ForEach over using just a regular ForEach. So this is how I would write this code. This is how everyone should write this code. And you'll see this list .ForEach pattern everywhere. I bet you might have it in your code if you go look yourself. I think you'd be amazed at how often this happens. I'm going to, I think I have to out a presentation to show hyperlinks. I'm going to show who does this. Well, here's a GitHub search. There's 80,000 files that have ToList. And if you start looking through here, you'll see that, okay, I'm calling a LINQ method cast, and then I want to loop over it, ToList.ForEach, ToList.ForEach. And this pattern is everywhere. And like I said, there's no reason to do this. 99, possibly 100% of these cases should just be regular ForEach loops. And and if you're writing like a little one-liner, advent of code solving problem, I mean, okay, who cares? But if you're getting into this habit of doing ToList.ForEach just because you won't want to write a traditional ForEach loop, your code is going to start allocating all of this extra garbage for the garbage collector, and it's just going to all add up. And if you do this throughout your code base, you're just going to cause a ton of performance issues for absolutely no reason. I think the ForEach method never should have been written. And you might ask yourself, well, why doesn't LINQ have it? Then you could just use that, and you wouldn't have to allocate a bunch of memory on the heap to make a loop so that you can use. The answer is ForEach is all about side effects, and LINQ tries to be more functional and doesn't like side effects. So LINQ is about I pass you values, I get results back. ForEach doesn't give you results back. It's void essentially. So because it's all about side effects, I'm going to loop and print something out or push it somewhere else or whatever. I'm not returning any results back to the caller. It just goes against the philosophy of something like LINQ, which tries to follow this functional programming paradigm. If you insist on wanting to be able to do .ForEach, just implement it yourself. It's a very simple extension method. Here's an example. Put that in your utilities classes in your code base. I mean, for all I know, there's some existing NuGet package that even has some extensions like this. But a few lines of code, write it yourself, and you don't have to call this just so you can call ForEach. So please remove that pattern from your repertoire of code. You can see that the perf difference, it's about on a large list 1.5 times worse in terms of wall clock time, how long it actually takes. But that's not really the main impact. This is obviously the benchmark results showing the time here. This is the benchmark results showing the allocation difference, the amount of work that we're creating on the managed heap for the garbage collector. And the first one doesn't allocate, so it's not doing anything. The second one is doing 100,000 times more allocations, of course, because it's actually creating an entire copy of all of the data. And that means a ton of work for the GC. So the other question that comes up is people think, and I've had this conversation quite a bit, well, okay, but I happen to know that the underlying data is already a list of some kind. Like in this case, I'm passing it to a function that takes an interval, but in this case, it actually is a list, right? And so isn't that just a no-op? It doesn't actually do anything. It just says, oh, this is already a list, so I don't have to make one. And the answer is no. It always makes a new list. And that's because by definition, the ToList method, as you can see down in the corner here, it creates a list. And by definition, create means it's going to make a new one. And there are lots of legitimate reasons where you might want to take an existing list and make a copy of it. And ToList will do that. And for thread safety reasons, I want to make a copy that I'm going to pass to something else, and I don't want that code to be mutating the existing list while I'm doing something else with it. Lots of cases like that. So no, ToList on an existing list still makes a copy of the list. So be aware of that. The other pattern that we see here all the time is calling ToList or ToArray just to get. So you can see a few different ways of doing things here. One is, and this is some code I actually found in a code base, and I love that they're using underscore for the variable in the lambda here. Unusual. But they're saying if some set of things has this predicate ToArray.length greater than 0 or ToList.count greater than 0, then go do something. Think about that. All I want to do is say, is there anything in this list? You could also call the LINQ count method to achieve the same thing. But why would you do that when the any method exists, which only has to see, is there at least one item in the list? And if there is, it returns true. ToArray and ToList, of course, are going to make an entire copy of all of that data. Once again, creating all of this extra data on the managed heap when it's completely unnecessary. And you can see there's actually, I have good and great here. This one, at least you're just calling the any method, and you're applying the where predicate, and then calling any. But even better is any will take a predicate, and you can just do that. So this is the preferred way here at the bottom of doing this kind of check, making some LINQ query, projecting, filtering, whatever, and then I want to say, typically filtering, is there anything after doing that? And let's look at some benchmark results. You can see, especially as the list gets large, just how massive the performance difference is here. And of course, the allocations are off the charts, but you can see the LINQ any basically is constant time. I mean, it doesn't really change no matter how big the list is. We really only see if there's one element. And then the where.any is twice as expensive. And then you can see it just gets worse and worse as we're only ToList.count and ToArray.length. Yet, once again, let's go look at some. Do people actually do this out in the real world? Yes, they do. Here's 3.6K files where people are applying this pattern. And again, I'm just randomly searching up. I'm not trying to call out any of these projects. I don't know anything about them. Some of them, are probably just one-off things. But when the any method exists, there's absolutely zero reason that you would want to be calling ToList.count. But this pattern all over the place. So if you are guilty of using this kind of code, a good question is why did you write the code? And I think it's these patterns that people get into where they just get used to it. Oh yeah, I have some a LINQ query of some kind, and I need to materialize it to a list before I do anything with it. And no, you don't. You don't need to do that, especially if the only thing that you're doing is wanting to see if the result is non-empty. Because remember, if you call .count, that list that you materialized on the heap is thrown away. It's immediately garbage. You can't access it. Right? I made a list here, And then I called .count, and I never assigned it to a variable. So even if the count was greater than 0, and now I want to get to like the last element of it, I have to do something else. I can't access that list. I made it and I threw it away. And that's just such a terrible pattern. This pattern that I've seen where people call ToList.count and ToList ForEach and all this kind of thing. Maybe so I started wanting to be able to search for code in these large repos that I'm working in that follow some of these patterns. And so I came up with this regex. I can just run this. I have a PowerShell function. The PowerShell is called bad. I type bad in the repo, I hit enter, and I just start spewing out all these places in the code where people are unnecessarily allocating memory. And then I can go fix those codes, or I can go yell at the person who wrote it, or more to the point, go to the person that code reviewed it. Say, why did you let this get into the code base? But this regex is actually more complex than it needs to be. For the most part, it can just be to array followed by a dot. The vast majority of the time you run a regex like this, you just look for ToList dot something. You'll find code that should be. Now, obviously, there are legitimate cases where that won't be true. It's amazing how much of the time that'll be the case. So once again, I'm going to go pull up some GitHub search results, and here we're just looking for ToList dot array, and right away we have. Hopefully this is big enough. So here's our console.read trim_n.split ToList.select .ToList. So we've got two ToLists in here. And of course, as we said earlier, split returns an array. So there's no reason to call ToList before you call .select. You could call .select on the array that comes back from split. And so that's an unnecessary heap allocation right there. And then ends, we've allocated an entirely new list after we've done the select, which is converting things to integers. And then we call the solve method. And you could say, oh, okay, maybe we have to call ToList here because solve expects the list. I went and looked at this code actually. Solve does expect it. But then the only thing it does internally is ForEach over. So it doesn't need a list. It could just be an IEnumerable. So we could change solve to take an IEnumerable, and we could get rid of all of these ToList calls. And now we've allocated massively less memory if this was code that was being called a lot, let's say. And again, all we're doing here is looking for ToList dot and ToList dot for each again. Here's a ToList dot select. Why? Why do we call ToList? Dot select can be called on the enumerable. You don't need this list. And again, we're making a list, throwing it away, and then doing a select. And this pattern is everywhere. 227,000 files. Now, like I said, there's legitimate cases where you call ToList and then dot on something. You know, there might be this specific method. The majority of the time, you don't need to do that. So the amount of code that is out there that is abusing ToList, it almost boggles the mind. And I called this talk tragedy of ToList. What is the tragedy? The tragedy is it's so easy to do. It's so innocuous. It seems so, it's this little tiny flourish of code that's right in the middle of things. And it is amazingly easy to fall into the trap of doing this. So going back to my slides again, you can probably run this kind of a simple grep on your code base and you will find bugs. Time. And here's a real world code sample that I found not that long ago. And setting up some stuff and sorting, doing some sorting and things. That's all fine. The main piece of code I want to focus on is this one-liner where we're doing a select ToList get range. And if we simplify this, and get rid of the math.min, let's assume there's at least 5 items. What this problem statement boils down to is given a list of key value pairs of string and int, take the first 5 items and give me their keys as a list. And let's say I need a list, so I'm not going to yell at the ToList at the end here because maybe I have to pass it to something. This is the problem statement. Think about how you would solve this. And let's go through some possible approaches. The first approach is the one we just looked at that was from some real world code sample that I found, where we call select, we call ToList, and then we call get, and we get range from 0 to 5. So 5 counts, so it's going to take the first 5 items. That's the first approach. We could reverse that, say, well, let's get the range first, because remember, we're starting with an existing get range is the method on list. And then we'll do our select to get the keys, and then we'll find a list. Approach number 3, we do the select first, and then we do the take, and then we call, or we do the LINQ equivalent of get range, which is take 5, and then we call ToList. Approach 4, we do the take first, then we do the select, and then we do the ToList. For approach 5, we can create a list and just write a loop. It's not a one-liner, but is it better than the others? Which one of these would you implement? And if you saw the first one, would it have raised any red flags? If you saw select ToList get range, get the first 5 items of some projection, would you have said, hey, wait a second, maybe that's not the best way to do that? Or would you have said, that's good to do? Because the benchmark results for this are dramatic. Let's focus on the list where there happens to be a lot of things, just because it's so much more obvious. By the way, the last one we did where we actually created a list and we loop is massively faster than all of the other options. 35 nanoseconds on a list of 1 million items. LINQ ones that are doing select and take are about 3.5 times slower. So where you do the get range first, which is dramatically better than the first option. But look at the first option. It's 231,000 times slower and allocates 83,000 times more memory. Because of course it's making an entire copy of the list. So go back to this and say, when you saw these 5 options, did you think that this one is potentially hundreds of thousands of times slower? Or tens of thousands? I guess it was the ratio. Yeah, hundreds of thousands, 230,000 times slower. And for a small list, it's 13 times slower. Obviously, this exacerbates because you are making this entire copy. But I guarantee you there are many programmers who would look at this first line of code and say, I don't see a problem with that. And yet the implications, if this code was being called in like a hot path or something, your code is going to be just unbelievably slow and be creating a ton of work for the GC for absolutely no reason. I have a little bonus anti-pattern here. It's not ToList, but it's in the same sort of category. This is another one that you see all the time. Select, and then I'm going to project whatever the item is in the list back to itself. Select x goes to x, dot where, length is greater than 20, and then I'm going to make a list. Now, if you run a benchmark on this versus removing the select, you'll see that it's 2 times slower, essentially, to just throw in this extra select. And you would ask yourself, who would do that? And once again, I'm going to bring up some GitHub search here. And you can see here's 12,000 files where people are applying this pattern. And of course, there's actually a lot more than that. Not everyone uses X for their lambda parameter. I'm just using that as And you can see here's all this select x to task, select projecting to itself reverse, and again, this pattern is everywhere. And why? Now it's not allocating additional memory, which is good, but or at least it's not doing something significant like this. But this is just an example of a completely unnecessary pessimization of the code. You know that term. We encourage people write non-pessimized code, which means don't write code that makes the computer do more work than it needs to for absolutely no reason. There is zero benefit for doing this pattern. So don't do this. I don't know why you would, but I see this code all over, and I've been fixing like hundreds of instances of it in codebases I'm involved. I'm going to do a quick demo. Let me go over to my other machine. And this demo is just to sort of drive home that, you know, looking at these code samples, it's kind of hard to really bring it back to concrete examples. But let's look at a very simple example of a web service. And let's say we have a web service that potentially could be heavily trafficked. What are the implications of something as simple as having an unnecessary ToList in the code? So I've written this browser. I've written a very simple web service. It's called from prefix. And the way it works is you give it a prefix. We'll say like AZ, and give it a count. I'm going to say 20. And it finds from the English dictionary all words that have that prefix. So we could say ER, and here's the first 20 words that ER, and so on. That's the web service. It's very simple. Let's go look at the implementation. It's just a simple ASP.NET Core web service. All it does is it basically reads in a file that has all the words of the dictionary. It creates a try data structure, which is a prefix, which is a good choice for this particular problem where I want to find matches with a certain prefix. It builds that. And then you have these two methods. One that uses the try data structure, says starts with, and then does a take on number that was requested. So we get the first 10, 20, 100,000, whatever. And then we have an implementation that has an ToList in it because we're one of those programmers that reflexively thinks that anytime I call something, I need to call ToList. And as we've seen, that seems to be something that actually is in people's minds. And I want to show what is the implication of doing that. So I'm going to use my favorite PowerShell to just make some web requests. And you can see here I'm selecting some words, and this is from the ToList variant. So it works in PowerShell. But let's do a actual. What I'm going to do is I'm going to make 1,000 calls. So this is saying, and we're running this measure command that will tell us how long it takes. So we'll make 1,000 web calls, and each time ask for words starting with C, give me the first 1,000 words that start with C. So I'm going to run that against the first version that is the regular, doesn't have an extra ToList call. And you can see it takes about 1.8 seconds to make 1,000 web calls. So it's, that's not terrible. They're all sequential. I could parallelize this and make clear. Now let's go call the one that is the ToList variant. Oops, prefix. And what you'll see is that it was dramatically longer, right? It took 6 seconds. Let's just see if it's consistent. And you're going to say, well, this is not a proper benchmark, but this is just going to show you sort of on a order of magnitude kind of, or just a rough granularity of what the performance difference is. 1.8 seconds roughly 6 seconds. So that's dramatically worse. And all we did is just add that innocuous little ToList call. And what's more is, Perfview has some, let me task kill Perfview. So Perfview, if you don't know, is a great tool for doing performance profiling. And what I did is I took a Perfview trace. I'm not going to do it live because it takes a little bit of time. I took a Perfview trace, both of those scenarios. I called 1,000 or 10,000, I don't remember. But I called it a bunch, and while it was running, I was taking the performance trace, and I did it for both of these two cases. So what I wanted to show is the GC stats. Oops, that's not memory. Here's the GC stats for the first version. Let me just get that over there so we can compare. And let's go to the GC stats for the ToList version. And we'll put that over there. And let me zoom in a little bit here. Zoom in. Hopefully you guys can see that. So here's our little demo service. So on the left, we have the one that doesn't list, and on the right, we have the one that does. And if you can see here, the view time 17 milliseconds or 17 seconds versus 49 seconds due to the unnecessary list. But again, what I was more interested here is in the memory profile. You can see here the total GC CPU time was 8 seconds. But over here on the ToList side, the GC CPU time, the time that GC was running on the CPU, is 25 seconds. So that's a huge difference. Total allocations, 600 megabytes versus 3.5 gigabytes. That is a massive amount of extra work that we're doing for the garbage collector. See the total GC pause time, where we actually have to stop everything so the garbage collector can do its work, which is a tremendous performance implication for your application if it's doing something that is like processing a lot of requests and needing to be as responsive as possible. 2.1 seconds of time spent in GC pause versus 4.7 seconds for the one that has that single ToList. And now that's one method call that's doing not very much, right? If you were writing an actual web service that has like hundreds or thousands of lines of code that execute as part of servicing a customer's request, and you're doing this ToList thing all over the place, but the amount of actual work that you're creating and the performance problems that you're introducing it's staggering. And this is the same data, basically, just in chart form. And what we can actually go look at that's kind of interesting is to look at, here's all the GC events that happened. And you can see over on this side, there's not that many, because we're not unnecessarily allocating a list. And if you go over to this one, we can scroll, we can scroll, we can scroll, we can scroll. You can see it's just way more events, which we would expect. But the other thing you'll see is that there's these, like everything over here is this induced garbage collection. They're all Gen 2s, which is what the 2 means here. And they're all the same. They're all just basically a regular Gen 2 collection. Over here, you see there's a bunch that are marked alloc large. And these are a Gen 2 background collection. And this means that this was something on the large object heap. And allocating on the large object heap is something that you want to avoid as much as you can, because you can get fragmented, and it's just more expensive in general. All of these large object allocations are just because we had that extra ToList in there that was completely unnecessary. And normally, if we wrote the method without the unnecessary ToList, you would never have any large object collections for that particular web call. So finally, that's not a proper benchmark. Go back to my slides, and here are the benchmark results. I did an actual benchmark. The memory allocation is irrelevant. This was actually benchmarking from an external app that's calling the web service. But you can see, the one with ToList is, five times slower, which is basically what we call the PowerShell. So that's the tragedy of ToList. It is such an innocuous little method, yet it can have such dramatic performance implications. And that's my talk. I'm going to now go over to Discord and see if there are any questions. And 15 minutes left. I nailed the time, so that's good. Let me go look at Solution2 chat. And we're just going to, I'm just going to scroll to the bottom and see if there are questions. Questions for what's the HTOP-like tool being used? It's like this guy. This is called Bottom. It is a tool written in Rust that is an HTOP-like tool. I really quite like it. I usually have one running in my terminal session. Let's see, C#, GC, Rust ownership, Swift, automatic reference counting, C++, or AII. Could you talk about these different memory management strategies? Reference counting, I've heard of. I've never worked on a language that does reference counting. And RAII and C++. I'm not a C++ programmer. I've written C before, but not C++. I'm going to defer to others to talk about those. GC versus C# versus Rust. Rust. The magic of Rust is that it achieves memory safety without a garbage collector, without something like reference counting, because it essentially does the memory management at compile time using the borrow checker concept. It's quite novel. It's very interesting. I encourage people to look into Rust if it's a topic that interests them. I got interested in Rust and did some work with it for a little while. But my day job is C#, and I realized that C# is getting so fast and it's getting so good at performance that there are very few problems I can think of where I would actually need something like Rust to achieve the performance of the stuff I work on, which is performance, massively large-scale web services. So, we evaluated, like, could Rust help us? And I think the answer is because C# is getting so much faster with all these improvements that if you write your code well and you don't sprinkle ToList throughout the whole thing, you can get really good performance, competitive with anything else. And I think there's a talk tomorrow on comparing C# and C++ and speed, and I'm looking forward to that talk. How worse is this kind of errant memory application when the system is memory constrained? It's much worse. If we're working in a memory constraint, I have the luxury of having 64 GB RAM or something on this machine, 32, I think. And in a memory constrained environment, it's way worse. And that's why you have to really think about things like, can I get away with allocating data instead of allocating? We didn't talk too much about stack versus allocation, but that's actually one of the tricks you can do to not make work for the garbage collector is to make more use of the stack. That's why we now have things like space that allow us to keep small stack and not have to allocate arrays all the time when we're doing things like converting bytes to integers and that kind of thing. So I see something about when I move, the sound gets cut off. I hope that's, oh no, that's not good. Was that a problem during the entire presentation? I will be really disappointed if my talk got ruined by my microphone being a problem. Oh no, I've never heard anyone say that, and I use this desk mic all the time. Well, if it's terrible, then I might have to redo this talk. It says it was mostly fine. Someone's asking, how do you split your terminal windows, tmux? No, this is just a Windows terminal. If I want to split, I can flip down. I just use the regular Windows terminal features. If you don't use Windows terminal, you should check it out. It's awesome. Okay, any other questions or any that I missed? I got a little bit alarmed when I saw the microphone comment. That was understandable. I guess that's good. Very sad if it's hard to understand. Rubrics for where ToList is appropriate. The big place I use this for when I want to take ownership of data. I mean, if you're going to enumerate a LINQ query multiple times, and it could be expensive, then you may want to materialize it into a list so that you don't have to reevaluate that expensive query. I think people that use the entity framework, that's a much more of a consideration. I don't use entity framework, but I use LINQ a lot, and so that would be one reason. Another reason is that often you will be calling a method that is in code that you don't own, and it takes a list. Hazel was asking about that yesterday. That's an example of where you would create a list. There are some tricks you can do, like you can do a pattern matching cast essentially to see if this is already a list. Just pass it in. Otherwise, call ToList on it, and that will avoid an unnecessary heap allocation. Someone asked about how you enforce these types of things to old dev shops, to list usage. You said you were manually clearing for usage from linter. I mean, honestly, there should be a code analyzer for this. I started writing one, and I just have been distracted and keep meaning to get back to it. My intent is that is to eventually write a ToListinator that is a code analyzer that goes and flags all these unnecessary uses of ToList. Because to be perfectly honest, ToList.ForEach, I don't think anyone should ever do. ToList.select on an existing query, or especially ToList.count greater than 0. Those patterns are all just, there's absolutely zero reason in my mind for them to exist. How do you handle re-educating teams that already have these patterns ingrained into them? I mean, it's education. It's giving presentations like this, and, participating in code reviews and flagging things like the code review that I had yesterday, where I said, hey, why are we doing this? You're calling split. You don't need to call. So yeah, it just takes time. And ideally, we would be able to do things like turn on code analyzers, which hopefully we'll be able to do eventually, and then enforcing those, not even letting people get into those patterns. Any other questions or questions that I missed as I was skimming? Well, if not, thanks everyone for coming to my presentation. Sorry about the audio issues. Hopefully most of it was understandable. And I will be hanging out on the Discord, and I'm always available to talk about these kind of topics. As people know, it's something I'm very passionate about. And with that, I will wish everyone a great afternoon, and please attend Stuart's talk on pattern matching that's coming up. I've seen this talk before, or a variant of it, and it's a great talk. Thanks everyone again for attending.